I got 20/90ths on hose A, and 30/90ths, which is 1/3 on hose B. And together they're 50/90ths. And then here I did 15, one more 5, which is 30/90ths. Here this is 1/3, and then hose B I did 15, which is 45/90ths, which is half of it. So in all I got 75/90ths. I knew I needed 15 more to get there. So I figured out that this 3/90ths times 3 equals 9/90ths, and then 2/90ths times 3 equals 6/90ths, and 6 plus 9 is 15. So that's how I got my whole bucket.
Because the 36/90ths that it takes to fill, that the hose A will fill in 18 minutes, can be added to the 54/90ths that hose B will fill, and together in 18 minutes they're going to fill the 90/90ths that Kennedy told us we need. That you're going to need 5 times that number because you have 90 parts that it's going to take to fill it. So you need to get to those 90 parts to make that whole. Sean, that was awesome, and I really like your clear work there. That's beautiful. Dan?
I just noticed when I guessed that it was 15.
Uh-huh.
I actually realized I was only 15/90ths off. So like.
And Sienna?
Can I go?
Sure, come on up.
Are you videoing?
Pardon me?
Are you videoing?
Yeah.
Hi, Sienna.
And Kennedy, your hand was up. Did you have something to add?
Yes.
Okay, let's hear what you have to say.
It's important that we need to know this because if if that came up in life, how would you do that on a calculator?
When would I?
That is a great point. How would you do that on a calculator? You have to use critical reasoning. You have to be able to set up the problem. How many of you said, as soon as I knew how to set up the problem, it was easy? Raise your hand.
I said that like 5 times.
Or felt that that was true. I'm seeing a lot of hands, right? Okay. And some of you, this is a really hard grapple problem, so keep listening because you might have an aha as you watch people solve it their own way. Go ahead, tell us about your solution, Sienna.
So this is A.
Let's lower that so it's not in the writing. I want everybody to see it. Can you bring it down a little bit more?
I see.
Here, maybe I can raise. Let's raise this. See if that helps. There you go.
I have a question.
Okay, let's wait till she shares and then you can ask that question. Okay.
This one was, so I had 1 minute would be 1 and 1:40. And then
So wait, Sienna, what is that representing? It's hose what?
hose B, hose A.
Hose A, in 1 minute, will fill 1/45 of a bucket. Okay.
And then I made it so it would do 90th. So then I did 1 again.
Can I show mine?
And then I did,
Sienna, why is it still saying 1 minute? Do you guys think that's correct? In 1 minute, it'll be 2/90ths?
Yes,
Yeah.
She's just doing it to she's just showing how you do it.
So why is she keeping it 1 minute, Penny?
Because they're equal.
They're equivalent. It's just another name for it, right? That's what you told us to do, actually. You said, let's find a common denominator. Okay.
and so then I did 45 plus 45 would equal 90, so it goes into 90 times. And then I went to do hose B. And then I did the same except with different numbers.
So the 3/90ths, why did you create that?
Because they're equivalent. Yeah. 30 goes into 90 3 times.
How is that helpful when you look at the two hoses? Why is it helpful to have them both have a 90 as the denominator?
I know. Tristan, no.
You can call someone.
You know.
I have a
Okay, Tristan, why would that be
Because
helpful?
they're equivalent and you can add them up. It's not like 60 and 500s. You can't just do that.
Okay, so you can add those fractions together. And what's the problem? What is in the problem that would tell us that you need to add them together? Tristan,
Wait, what?
what is it in this problem that makes you want to add those together? What part of the
you can
problem?
Find out the answer. No. The bucket. How many? Wait, what?
You said that it's helpful because you can add it to find the answer.
Yeah.
Well, what is it in this problem that makes you want to add them together? What's the question asking that makes you want to add them together?
How much it can fill up in a minute and how many minutes?
Is it just talking about one hose?
No, it's talking about two hoses together.
So because they're together, you have to add them together. Sienna?
You need the same denominator because they won't. You need the same denominator, and then that's the only thing that both will go into.
And then you can add them together to see how much together they're filling up in a minute. Okay.
So then I did A and B together right here.
Hose A and hose.
So then I did 2 plus 3 equals 5, and then the 90th. And then I did 5 times what would equal 90? 1 whole. And so then that was 18.
Okay. I think there's one thing that I would change on this or improve. If you have an idea, raise your hand of what you would suggest that Sienna revise, because her thinking is good.
I just need to know.
Dash, what should she revise on this?
Isn't that she said 1890th?
Yeah, I'm like
So
raising
that
my
would
hand
be
for
like-
the head.
So Sienna, do you mean that you would have 18 iterations of 5/90ths, but would you have a 90 in your denominator of the 18?
No.
What would that be, gang? What would that be?
That would be no, because if you did that, if you did the 90th, that would be 90. That would be 9,800 and
It would be 8,100.
The equation's going to be 18
Yeah.
times 5.
It would be 8,100.
yeah.
8,100. So right here, Sienna, you're saying 18 minutes, right? Or 18 iterations of the 5/90ths. So you're taking that 18, it's the whole 18s, okay? So can you just write that there's a 1 under there? Do you guys agree that 5 times 18 is 90?
Yeah.
Is 90 times 190? Okay, and is that a whole? Yeah.